Assalamualaikum warahmatullah. Okay, now we continue with the DC-DC boost converter. Okay, slide from the touch again as well. So we shall discuss accordingly. So the assumption we make for this boost converter is that the output voltage will be higher than the input voltage. So boost means that we shall step up the input into a higher output. So means that the output will be much higher compared to input boost. Boosting up, and the analysis will be taken place or we consider at steady state and continuous conduction mode, CCM, steady state, and also the inductor current to be at positive, always be at positive, and the capacitor we assume to be very large, and the output voltage is held constant at V out. So the inductor is continuous current, the current inside inductor is continuous, positive, capacitor is large enough, and all the components here are ideal. Switch, the S1, S2, the diode here, MOSFET here, and all the components are ideal, and the switching will take place on the D duty cycle from 0 to 1, 100% of T. So this is the assumption that we make for step up DC boost converter. Okay, we take a look at the circuit on the on state and off state, on the topology and on the behavior and response of the circuit. Then we go into the formula and the equation. Okay, assume now that S2 here is composed of a diode, S1 from a switch, might be a MOSFET, a limiter, or whatever. So far we consider as manual switch. So this is the on state, or when the switch is closed, and this is the circuit when at off state and off state. So when the switch is closed, so what happens is we take a look from the inductor point of view, in terms of their voltage and their current, and voltage and current. When switch on, we analyze the switch on. When switch on, the current will try to flow at the lowest resistance possible. So it cannot go here, because what, we have resistance here, and we have resistance at the load. So it prefer to go to the zero resistance, which is the switch, which is short circuit or switch close, and return back to the source. So you can see that the amount of V cross L is the amount of V source. So VL is the amount of V source parameter. And when the switch is closed, off state, off condition. So what happened? The switch is closed. The switch is off. And when the switch is off, so you have a open circuit. So the current cannot go here because open already. So instead it will go through the diode. The diode, when it forward bias, we consider as short circuit, ideal. By right, we have a voltage drop, but this one we consider as ideal, so there is no voltage drop. So we consider as the circuit is fully connected. So it flows to the diode, to the load, back to the source. So the VL is equal to, now VS equal to VL plus V out. So VL is equal to VS minus V out. VL equal to VS minus V out. So by right, the portion here is higher compared to here, by right. It's not the same, because this one is VS, this one is VS minus V naught. Should be lower. Alright. Okay, this is the pattern or the curve or the graph that the voltage output when we see from current inductor point of view. In terms of current, when we switch on, so this is on, this is off. So when we switch on, what happens that the current will build up. We consider it as the data or the curve taken at steady state. And so it will ramp up from a certain level up to the duty cycle. And ramp up. Once the duty cycle reach, the switch is off, it will reduce down to the same level of where it starts from. Okay, start from here, and here we turn down here. Let's say if you squeeze the D here, so we rise here and return here. Okay, same like buck converter that we discussed previously. Okay, what happens that when you switch on, it goes here, it charges up your inductor. You will switch off, the polarity will change. Just now, the current flows into the circuit, into the inductor, so positive and negative. But now, what happens that the polarity will change. Here become positive, so it will build up, and builds up in terms of their voltage, and return to the circuit, to the load. Meanwhile, if you take a look at diode point of view at on and off state, so when we switch on, there will be no current throughout your diode, because all the current go through the close or the on switch of the S1, so no current. But when you switch off, the pattern will follow same as the current that flows into your inductor. Whatever goes inductor will go into the diode, but it will ramp down linearly to the high minimum. Okay, this is what happens inside your diode. And the current divided into capacitor, IC and I out. So what happens in IC is equal to IL minus I out. So IC equal to IL minus I out. So that's why we can see that the range shifted down per V out divided by R. So I out equal to V out divided by R. And V equal to IR. This is Ohm's law. So we shifted down to the value, but still follow the same pattern from duty cycle up to T. Okay. So based on the slide, when the switch is closed, means that when the S1 is on, this one is on here. So VL equal to VS, which is L dL dIL over dt. So we can see that when we solve this equation, the delta Li here is equal to Vs dt divided by L. So we can see that when our area here, this is the area of delta IL when the switch is closed. When the switch is closed, so the area here when the switch is closed equal to Vs dt divided by L. And same goes when the switch is off, open circuit here, means that your equation will become Vs minus V naught 1 minus D times T divided by L. So this is happen when the switch is closed, switch on and switch off. And ideally this is on, this is off, on, off. Ideally the on and off state should be equal to 0, and IL close and IL open should be 0, because the inductor should not consume current, just store current. So when we add up this together, means that it starts from certain level, it backs to certain level, and means that it does not consume, it just deliver and absorb like that. So when we combine these two equations together, so we can see that V output is equal to Vs divided by 1 minus D. So the V out is equal to the amount of Vs divided by 1 minus D. Means that if we increase higher in terms of duty cycle, the output can be gained higher. And 1 minus D, if 0.5, 1 minus 0.5 is 0.5. 1 minus 0.9, so become 1.1 as 0.9. Okay, means that the higher the D, the higher the Vs. And so as D increase, the denominator of V out become smaller. So this one becomes smaller, Vs become higher. So it result a larger output voltage. And also it was stated that the input current In is the same as inductor current. So whatever that comes into the circuit from source will pass through inductor and will go to the load. So it means that the current that comes into the inductor is the same the current measured in the load. Okay, also the power, the input current, the input and the load is the input and the inductor is the same current. Average power absorbed or supplied by the source, absorbed by the load system or supplied source, is the same as average power absorbed by the load resistor. The power delivered is the same as power received by the load, because inductor and capacitor and as well as the diode here we assume as ideal, so it does not consume any power. So whatever delivered is absorbed or consumed by the resistor, the load. And the maximum and minimum inductor current are determined by average value and the change in current. So we can see, or we can set the I inductor value and maximum and minimum based on the equation here. You can see or refer the details from the books, reference book. And your positive values of IL max and IL min, the converter will operate in CCM. If it operates in positive, the swing of minimum and maximum here in positive mode, so consider as CCM, continuous conduction mode. If you want to see, or we want to set, we want to find out what is the minimum in the boundary, so the minimum inductor value, we can see, we can set the IL min at 0. Just now we have value. If we set IL min here at 0, 0 equal to IL, so we can get the minimum inductor value. Means that the swing will be still in positive, but it will end at 0. I minimum 0, swing up and down to 0, up and down to 0. So I minimum equal to RT divided by 2, 1 minus D squared times D. So as per discussed before, by right you should be able to foresee in terms of when you take a look from inductor, diode, capacitor point of view, in terms of their current, voltage, you should be able to predict or draw their pattern in terms of their response. Okay, we shall discuss in the next coming slide for further discussion.